Hello and welcome to Mathematics with Simon. I'm Simon. Today it's an introduction to the beautiful, powerful, wonderful subject of algebra. So what is algebra? Algebra is doing mathematics with letters that stand for numbers. That's what it basically is. It can help us to solve problems like this. So if I say think of a number, double it, take 5 off, what do you get? If the other person says 17, then I can work out what the original number was. Or problems like this. Joanna has £25. She had £41 when she left the house this morning. In between, she bought 2 shirts, 2 identical shirts, I might add. She didn't spend money on anything else or earn any more money. How much did each shirt cost? Problems like this. 3 bats and 2 balls cost £12. 2 bats and 2 balls cost £10. What does a bat cost? And what does a ball cost? A car accelerates at 3 meters per second squared. It's travelled 24 meters. How long has it been going for? Oh, by the way, it started off at 0 speed, so it started off from rest. We also have algebraic formulae, where letters stand for different quantities. So here's one. PV equals C. Pressure times volume equals a constant. This is called Boyle's law. Force equals mass times acceleration. F equals ma. This is Newton's second law. And P equals 3W plus 1D plus 0L. This is the number of points that a team has got in a football league. So W is the number of wins, D is the number of draws, L is the number of losses. So your points are 3 times your wins plus 1 times your draws plus no times your losses. So actually, algebraic formulae crop up all over the place. They also crop up in different branches of mathematics. So we get them in calculus, which is the mathematics of change, in geometry, which is about the 2- and 3-dimensional space in which we all live, in probability, which is about the chances of different things happening, and in mechanics, which is the study of the physical world. So they crop up in all sorts of different parts of mathematics. So when I was younger, like by a lot, like when I was 7, we got problems like this. 3 times 4 plus 2 equals box, fill in the box. Or 5 times 6 plus 7 equals box, fill in the box. And then, further down the worksheet, it would go like this. 2 times 3 plus box equals 11. 3 times 5 plus box equals 20. What goes in the box? And then this. 4 times box plus 1 equals 17. 2 times box plus 7 equals 23. And again, we'd have to fill in the boxes. So let's have a go at these. So 3 times 4 plus 2 equals box. What goes in? 14. And then the next one, it's like 30 plus 7, 37. These ones are a bit harder. 2 times 3 plus box equals 11. So 2 times 3 is 6. So what's the box got to be? The box has got to be 5. Actually, in both cases, the next one's 15 plus box equals 20. And this one's a bit harder. So 4 times box plus 1 equals 17. But I think we can say, well, 4 times box must be 16. And 4 times what is 16? Well, so probably it's 4. And then the next one, it's 8. 2 times 8 is 16. Plus 7 is 23. We're sort of working backwards here, though. There's a general feeling that we're working backwards. But we could have written these problems like this. Instead of putting a box, we could have just put an x and then say, what is x? So 3 times 4 plus 2 equals x. What is x? 2 times 3 plus x equals 11. 4 times x plus 1 equals 17. In that case, we don't write the multiplication sign. We just say 4x plus 1 equals 17. So let's look at those original problems that we set and work out how we can use algebra to look at it. So with this one, think of a number, double it, take 5 off, what do you get? So what we're really saying is 2 times the number minus 5 was 17. And then what we're able to do here is, because these things are equal, because 2x minus 5 equals 17, we're going to add 5 to both sides. 2x equals 22. So if you add 5 to 2x minus 5, it just comes down to 2x. And then if we add 5 to 17, we get 22. So we got 2x equals 22, and then we divide both sides by 2, which tells us that x equals 11. Okay, let's look at the next one. Joanna has £25. She had £41 when she left the house this morning. Okay, so what we're saying is £25 that she has now is the £41 she had minus 2 times x, which is the price of a shirt. What is x? Well, what we can do actually is to first add 2x to both sides. So if we add 2x to the right hand side, we get minus x plus 2x, which cancels out. So we just end up with 41. And then if we add 2x to the left hand side, that just puts plus 2x on the front. Then what we do next is we take 25 away from both sides. So taking 25 away on the left just cancels out the plus 25. And taking 25 away on the right, you just get 41 minus 25, which is 16. So now you get 2x equals 16. And then divide both sides by 2 tells us that x equals 8. This one, 3 bats and 2 balls cost £12. 2 bats and 2 balls cost £10. What does a bat cost? And what does a ball cost? Okay, so we can write this like this. 3x plus 2y equals 12. 3 bats plus 2 balls equals 12. 2 bats plus 2 balls equals 10. And then what we're going to do is we're going to take the bottom equation away from the top equation. So if we take the right hand sides away from each other, you get 12 minus 10, which is 2. And if you take the left hand sides away from each other, you get 2y minus 2y, which just cancels to 0. And then 3x minus 2x just cancels to x. It's a bit like saying 3 apples take away 2 apples. That's just an apple. 3x take away 2x is just x. So this leaves you with x equals 2. Now, we can sort of see this when we looked at the problem, because we'll say, well, 3 bats and 2 balls cost 12, 2 bats and 2 balls cost 10. So the difference between them is like one more bat. The top example is just one more bat, and it costs £2 more. So that bat must have cost £2. And then now we know x is 2, the price of a bat. We then substitute it back in. So we substitute it in here. 2 times the price of a bat plus 2y equals 10. So what we've got is 4 plus 2y equals 10. We take 4 away from both sides, which tells us that 2y equals 6. We divide by 2, which tells us that y equals 3. So the price of a ball is 3. So actually the balls cost more than the bats. Oh well, maybe that's right. And then the next one, a car accelerates at 3 meters per second. So this is an example of a formula. Car accelerates at 3 meters per second squared. It's travelled 24 meters. How long has it been going for? So here we can use this formula from physics. S equals ut plus half at squared. S is distance. U is the original speed, the initial velocity, which is 0. A is the acceleration, and t is time. So what we've got is 24, the distance, equals 0t plus a half 3t squared. And then what we're going to do is we're going to multiply both sides by 2. So multiply the left by 2, 24 goes to 48. Multiply the right by 2, and the half cancels, and we end up with 3t squared. 48 equals 3t squared. And then we're going to divide both sides of this equation by 3. So 48 divided by 3 is 16. And 3 divided by 3 is 1, so we just cancel that. So 16 is t squared, and if 16 is t squared, we know that t must be 4 seconds, because 4 squared, 4 times itself, 4 times 4 is 16. So this has been a quick canter through algebra. Wow, time flies. I didn't expect it to come to the end so quickly. I've really enjoyed that. I hope you've enjoyed it too. If you have, please press the like button. And if you'd like to see more in the future, please hit subscribe and the bell, and we will send you more, and then you'll be notified when it comes. Most of all, I just hope you're enjoying your mathematics. If you're locked down at the moment, I hope it's not too bad. I hope you're finding a way to enjoy yourself. We'll be sending you more maths videos soon, and I very much look forward to seeing you next time. If there's anything you want or anything that interests you, if you just write it in the comments, I'll try and do that. But probably what we're going to do is more algebra videos coming up. And then after that, maybe some more calculus videos. And after that, decimal numbers. Anyway, we've got ideas. Look after yourselves. See you soon.